Today we'll be looking at file handling with C++ and what and how or some examples of how file handling is being used in game development in C++. Last 2 weeks we did classes and object oriented program is in C++, and today we are going to deal with file handling with C++ classes and game development. So today our topic will be creating part 9, and as I said, today will be our last basis of the C++. So next we will be looking at libraries and then other these things that we can use to create games. So today is part 9, and we said file handling. We're doing file handling with C++. C++, and what in game development. So let's go through what file handling is in C++. So we say file handling is used to what store data permanently in the computer. Using file handling, we can store our data in the secondary memory, maybe the hard drive or maybe the SSD. We have already used this IO stream before in our codes. So what streams are in C++? They allow us to read a sequence of what bytes in a given input when we are executing a program. For example, when we are taking input and output operation between the executing program and devices like keyboard and the monitor, we are using the streams to get those IO inputs or IO operations from those devices. So we call them the disk IO operations. That's when we are taking input and output. So we have some few classes that are for file streams operations. So classes for file streams operations. And then the first class we have is iOS, not to be confused with the iPhone this thing, iOS. But iOS stand for input output stream. So basically what it means is input input what output input output stream. So that's just the definition of what the iOS. So what does the iOS do? So it's a base class for what the other what input and output or streams to what inherit from. So if you look at here, we say iOS stands for input and output stream. This class is the base class for other what classes in this class what hierarchy. This class contains the what necessary facilities that are used by all the what above and what other driven what classes for input and output what operations. So these are example of what input and output what classes that we'll be using. So first, let's first look at iStream, uh, where this thing is coming from. We have iStream and we have what OStream. So here we have included what IO stream, input and output what stream. But each of these things are what separate what classes. So when you said hash include IO stream, each of these are inheriting from what the iOS what class. So it's like it's the base class and then these ones are the drive class. So first we have what the iStream. So the iStream stand for what input stream. So we just stand for input streams, and as the name suggests, it's also derived from what the iOS what class. So this one is drive drive. I don't know if my drive is spelling is correct. Drive what from what iOS stream, the iOS. This class, the base class. If you don't understand what we mean by drive classes, you can check here. We have defined what classes inside there, what base classes and what drive classes, and also there is some PDF containing those things. Um, drive, and we said this class it handles what input what streams. So basically, what is that is it handles input streams. So we say it handles what input what streams. So we use what the extraction operator. So it uses the extraction operator. And then I think the other time we explain what an extraction operator is this operator. This is the extraction operator. So we overload the extraction operator in this class to handle what input stream from what files to what to the program to what execute. So this class like it declares input functions such as what get and then what get line. So we have the get and get line, and then we have the O stream is also derived from what the array stream, and this one handles what output. And then for this one we use what the insertion operator, insertion operator, which is this less than. So when we combine these things together, that's when we have what IO stream, input and output dot stream in C++. So basically this is where these things come from. So we are importing what importing IO stream, which are what also inheriting from what the iOS what class, which is the base class. And we have another one which is stream buffer or stream buff. It's spelled like this. stream of, yeah. So this one is a class that contains pointer to which what points to the buffer which is used to what manage the input and output what streams. So let me add the explanation here. This class what it's a class, so it contains what a pointer, and we already learned what a pointer is. So if you, and I think around, is it past 7 or which part? Yeah, I think past 6, somewhere like that. Yeah, past 6 we learn what pointers are. And then there is another PDF too there. You can go through it and check how pointers work. So we say this class contains a pointer to which points, but for quick explanation, we say pointers are just like um, memory. They store what memory addresses or memory locations. Yes, so that's the simple definitions of pointers. They just refers to what they refer to a memory location. Points to what the buffer which is used to what to manage the what input and output stream. Input, output, output streams. So that's what the stream buffer is. And we also have the F stream base. It's also a class that provides operation common to the first stream. So it serves as a base for the F stream, if stream, and what upstream what classes. So these classes, these classes, that's where um what the F stream base is serving. But we just look at what the if stream is upstream, and then what the F streams. So the if stream we say is what this class is used for reading data from what a file. So that's just the basic usage. It's used for reading what data from a file. It's inherit from what the F stream class and provide method for opening and reading what from what files. So it's this one inherit from what this class F stream. And we have the upstream. So we said this class is used for writing data to a file. It also what inherit from what the F string and provide method for opening and writing to file. If the file doesn't exist, it will what created. So if the file is not there, it will what create a new one for you in that order. So any question before we jump into some examples and write and see how we can use the F stream, the O stream, and the I stream or if stream to what create and read to a files. Okay, if no question, then let's create our main function here. And then in order to work with the files, we need to include what the header file for what the F stream. So we said hash include F stream. So this is the class that we will be using for what the input and what the output. So let's say we want to create a file. For now, let's see how we can create a file and then write what into what the file. We put something into the file. So we'll just create a simple text file and then what write into it. So when we are creating a file and we are writing into it, or we are what outputting into it, we use what the what FOF what stream, which stand for what output what stream. So here we have to what add the standard, but if we want, we can also use what add this here using what namespace what standard. So this the scope operator won't be what required. So we'll create an instance of what of stream and we call it out. So here we have what created an instance of this. Let's just return 0 here. So here we have created what an instance of what the of stream. So here say what creating what creation creating instance uh, instance or what class what object of what the of stream. So now when we what create what the file, we have to what write into it, maybe put something, we have to what open a file that we want to what put the text into. So to open a file we use what fout dot open. So as we already look at, there are two ways. If the file is not there, it will create it, but if the file is there, it will what override it and put what um and put the file the data that you what trying to the new data that you are trying to put inside and pass those ones what inside. So by default this is the open here, it takes 2 or 3 parameters here. So we have what the file name, which is a pointer to a character pointer, and then we have what the ROS base, which checks what the open mode, the mode that you are opening the file in. So by default the open mode is what iOS out mode. So it automatically deletes the content of the file. So but if there is what already what file that is there, it will automatically delete the files and what append the new put the new file inside. So it's just like overriding, it will just override the old files and put new file inside. But if we don't want it to override the old file and what and put the new files, we'll use what the iOS app, or what we call the iOS append, so that it will append that the files what to the what to the already what existing file. So we say by default we have what the iOS what out. So this one is passed by default here. So this one we just override what anything that is there. Overwrite anything or what in the what file. But that we have the iOS app, or which stands for append. So this one will what add, it will open and append what append to what to the file content. So here let's call the file on sample file dot text. So by default we can there is already this thing paths the mode pass this mode is path the iOS out. So if one we can say iOS, then we have what append. So we have changed the default behavior to append. Instead of it overwriting the file, we just say okay, append what those new files that we want what inside instead of appending them. So now to add new files inside the files that we just opened, what we can simply do is what we call the f out, and we use what the operator, which we call what the insertion word operator. You see that we have defined it here. The insertion operator is just like the cout that we have. So we just pass what my sample text file. So here we are just saying the end line, we are just saying she what end line. Then after everything, when we are done creating the file, opening it and what adding our content inside, the most important thing is we have to what close it. So we have to close the file. So now we have opened the file, put this text inside. So here we are adding what content to the file, and then after adding the content we close what the file. So here we what open the file, and what append to the file of content. So that's what we are doing. So right now let's compile the code and see whether we will get a file created within this list. As you can see, we don't have a file name sample text here. So let's compile this in plus say basics underscore fact. Huh? Let me this open a new command prompt. Okay, then plus. So we say basic dash o. I'll call this output file call this basic 9. So we have compiled the code. Now let's run it. Basic. So let's run it and see. You see when we run the code, the executable, you see that we get what a file here. This file was not already there. So now we have what created a new file called what sample text. So when we open it, you see my sample text file. So we have what push this file inside what my sample what text what file. So basically this is how we would add text to what to the file that we created. So to add, if one we can add more what content or more text into it, so we can just say let's print this stars here. So when we compile again, then we run again. When we open the sample text, you see, and because you see that we got repeated here because we are what appending to what the file what created. But if we change this one to out, let's change to this to out, and we save, and then we compile and we run again, and we go back to the text. You see that we have got only these two because we have what overriding what the text. So old text that was there, we have what deleted them and put new ones inside. And then after everything, we close with the file. So that's how we can what write or what save to what a file. So now after that, let's see how we can what read from what the file. So as I said, to read we use what the if stream. This we use what if stream here. So this class is used for reading data from what a file. So let's see how we can read the data from what the file using what the if stream. So that one too, we have to create what an instance or the class object of it. So we said here creating instance or what class object of what the if stream of the if stream. So here we say if stream, and then we give this one in, just a simple name for this. So to read from the file to we have to what open that same file. So we have to just open it like the way you open it when we were what writing to it. So we say what in this one the instance or the class can be any name as we already learned. So just said this, we open what sample. You have to make sure that the file name is what you have the same file name so that we won't get error when we are what opening what the file. Okay, so now we have opened the file. It's now left with what reading what the file. To read the file, we can use the insert what is the name? This operator, the extraction what operator rather. So when we come here, we can say let's add the string class here so that we can read from the content inside the file because they are strings. So let's come here so we create a new file called string and call it contents. So here we say thing. Since we are using the extraction operator, we would use this and then we would pass the content to it. Then when we would print out the content, so here we say content and file. So after that, we would close what. So whatever we do, we have to what close the file. Whether we are reading or we are what writing this to the file, we have to close the file after. So let's compile and let's run. You see, we'll get what content in my file is. So the reason why here we are not getting anything here is because this thing is not what reading what the full file from this. So we have a way of what doing it, like a better way where we can read the whole file what from what this sample text, the sample text what file. So what we can do is let's comment this. We comment this, and then we use a while loop, and then we use the get line function. Then we pass the fin, and then the content. So yeah, that's it. So we use the get line, and then the fin. So we say fin while the get line is also like the scene that we use to get um input from the user. So it's just the same thing, just the same way we are going to use this. So we can then print out the content of this, or we can just copy this and put it here, and then we compile, we run. You see that we have getting all the text inside. So we have gotten them line by line. So this one will allow us to read the text line by line, like each line per line, in that order. Forget about this red squiddle lines here. We don't need this thing for the compiler to work. We don't need this. I don't know why this thing is highlighting this. Um, anyway, but this one is not an error, so it shouldn't be displaying error here, but anyway, since it's just doing, you can leave it like that, but it will compile and it will work. So let me redefine this content in file, then we remove this. Let's remove this one here. So that I want it to print nicely, so that we'll be able to see the text. Compile. So we have content in file, and we have the content inside the file. So we have two lines. So if we were to add even more than one content inside the file, like for example, if we add this, if we add this and we compile and we run, we see that we get all the files inside, all the content inside the file here, everything printed out in our console. So now we have seen the basis of how we can use F streams. So these are some of the examples that I've created inside. So this is another way of doing it. So yes, create the object and initialize it directly inside the constructor here. So this is another example that you can do it. So here the same thing here. This one we are using the output. We are printing. This is the whole program put together. So let's see how we can use it to in game development, maybe saving the player data and then what getting the player data. So first, to do that, we have to create our player what class. So let's say class. This one is just an example of how we can use this to create a store our player what data inside what the game. So we define our class and we add our public access specifying. So let's say we have string, our player name, and then we have int the player health, and then what again? The level. Let's just say level, the level, just in case maybe when you are playing the game. So now we will define our function here to save what our player data. So we say save player. Let me make this one small. Save player data. So this is the method that we use to call and what save the what player data. So let's call this one file name. But when we save each player, we have what the file name in addition, so that we'll be able to what specify the file name of the player. So first we have to what create the file. So this one we are going to what use the constructor method or constructor way. So we say upstream. We have what out file, and then we pass what the file name to this, and it must be a string. So that's why we just pass the file name in there. We don't have any other error. So here there are two options. Is we can what add this thing to it, or we can make it append, or maybe just overwrite it and all those other stuffs. Then let's use another method within the offstream. So we can say if the output file is open. So this is another method within the offstream. So here we are basically saying if the file is still open, then we are going to what save the data inside what the file while the file is what open. So we say out, then we use what the operator again to what put the player what data inside. So first we have the name, the player name, then second we have what the player health, and then the level. So to make this thing more readable, let's just add this inside. So let's say player name, uh, player health, order, player health. And then here we have what player name, and then here we have the player level, so we have what save our file. So when we are done, as always, we have to what? It's a must that we what? Close the file. So we just say alt file dot close. We close it, and then we just say layout layer data what? Saved. Saved successfully. So we just save the after that we will just print out this message once the data is successful saved. But if not, so we just say if the data is not saved successful, then we just say we are using the C error from it's also from the iOS streams class just for printing errors. So we just say error saving what layout layer data layer data save error. So that's basically how we create our class, our player class. And so now let's go inside our code here. After all this, we create an instance of what? An instance of what? Object of what? Our player class. So we say player. So we say player one. Player one. So this player one, we set player one dot name equals to what? Player one. And then we get what? The health. Yeah, let's make the health 100. Then the level, let's make it level 1. Then the player dot the file name, which is very important, we just call it player 1 dot text. So we have what? Created our player object. So now let's call the save method. Now let's compile our program and see. And now we run. You see we have what? Our player what data file was created. So we have the player name player 1, the player have 100, the player level 1 inside here. So we have everything what inside here. So that's how we can save what the user data. So with this we can even create another player, maybe a different player. So since this one is player 1, we will create what player 2. Let's copy this and paste it here. Then we'll change everything. We'll change this to player 2. So here we say 2, player 2. player 2. This one we make the health 50, the level 5, and we save the player 2 too. Now we have what? So we have what? Player data save successful. So we have what? The player 2 here with the name, the health, and then the level. So we have been creating the, but let's see how, like, how can we what, get the data since we have saved it. Let's see how we can get the data. So we have a saved data, we have saved the data. Now let's get the data. So we need another member function here. So this one to just say void get player what, saved data. So to get the saved data, we use what, the if stream, or the what, we use this if stream here to what, to read the data. So we create what, if stream. So we have if stream, and we can call, let's just say infer, or let's just say player data. You can give it any name you want. We'll just pass the file name here, player data, because that's what we are trying to get. So here too we can just say if the player data dot is open, the same function. If the player data is open, then we get what, we get those what, data, each data from what, the player, and then what, print them out. So here we use what, the while loop again. So we say while get, give the get line, and we say player data. Then we will need to create a string here. If we are reading like a single line of files, if one, we can just use the file data type. But this one we are just reading from the string of what, the player. So we just used string. So we just say string all player did save data. So this one we just call it all player save data. And we pass that one to here. So let's just add cout here at the top here, saying getting player. So we just add the player name here. Name. Then we have saved data. Then we just cout. They're all player data. Then after that, we what as usual we what close the file. So we say player data dot close. Very important. We have to close the file anytime we are done with reading from it. And here too we can add our else statement here. And then we just use this. So here instead of saving, we just say getting player data with field. So we just say getting player data with field. So now if you come down here and then when we call the save player one dot save, let's call what player one dot get the save data so that we see the output. Let's compile. So you can see player data save successful, and then we have what getting the player one was save data. So we get what the data and we print them out. So just get them here and then print everything out. So we can print out what the player two data. Same way. The same way. So we have the player one and then we have what the player two. So this is how we can get and save the data out of the player. For more advanced this thing, we can use pointers to pass for the file name or maybe even the whole player data inside. Let's say we are working with another file outside. So we can use pointers for that or maybe references for those kind of things. So that's how pointers works. Hey, sorry, files, we can use files to what? For game development. So I've added another example here, but this one we are using struct. We have the save method and then what get method. So we have the common file operations, we have the open, the read, the write, the close. As we said, saving game states, how it is used in the game development, like levels, the player inventory, how position, all can be saved using that the host streams. So this allows what the player to resume what progress what later if you are playing again or maybe loading levels. The levels that we say we want to load them back to the games and so forth. High scores and maybe settings, configuration files, difficulty, graphics options, and all those kinds. There's some complexity behind the scenes, but basically this is how most of them are is being done. But there is some other distance that is behind the scenes. So benefits of using the classes, the file classes. We have error handling, abstractions, and what readability. So I think that's all for file handling. As I said, next week we'll be looking at libraries and maybe some frameworks that we can use so that we start the real game development. This thing we look at Raillit or SFML and all those other libraries and frameworks used in game development. So without further ado, we'll be closing for the day for files and handling files in C++, classes and Gendo. So that's it for today. Any question